Yay, hey, I can hear myself. Hi, good morning. Good morning. How's your project going? Good. Thanks for coming in. I know we're taking time away from you working on your projects to have the tech talks. We do appreciate you guys stepping in here and joining us. I also understand you're going to keep working, so it's cool. I won't take it personally that you're not like totally paying attention, but it's really my privilege to be here to give this talk. I call this talk "In the Footsteps of Giants." I have been around this industry for a long time. I've worked for a lot of the big tech companies. Someone asked me what in the talk title, it's FAANG. It's Facebook, Apple, Amazon, Netflix, Google. The FANG acronym is very popular in tech circles. It just represents the sort of the pinnacle of technology companies, if you will. There's lots more. Those aren't the only ones, obviously. There's a bigger cadre of them out there. But for those of us who aren't at a FANG company or aren't in that upper echelon of highly recognized technology companies, working with developers is still really, really important, but it takes on a whole different tone, and that's what this talk is about. So before I begin, like I said, I know everybody's taking away from your code time, and I appreciate it. I hope you took a minute when you walked in here to stand up and stretch. If you didn't, do it. Your body will thank you for it later. I highly recommend it. The days are long, the nights are long. So make sure you take care of yourself. So who am I? What do I do? What does my company Ansys even do? My name is Chris Harold. I have been around developers and developer relations for the last 15 years now. It feels like shorter, but that's because COVID was that weird 4-year period where nothing happened. But I run developer relations for Ansys. And what that means is I do a lot of work with our internal developers and also with external developers. We sponsor events like hackathons. We attend various developer conferences, and we try and engage people around what Ansys does. So what Ansys does is physics-based simulation of pretty much everything. We simulate everything you can see up there. So if you can build it, make it, walk on it, fly in it, drive in it, sit on it, it emits light. We've probably simulated it in some way or another. There's an easier explanation for it. So basically what I tell people is we have boxes, not boxes of puppies, sadly, boxes of math. And that math is really specific and solves very, very difficult challenges. The problem with that is, like a lot of companies who didn't grow up in the born digital age, like we're not a startup. We've been around for 50 years. Those boxes of math contain some of the most complex and difficult math on the planet. It's incredibly difficult to understand without a high level of PhD. And even our high level of PhD employees who write it don't always fully understand it because physics is always evolving and it changes. And so we have a problem, right? There's a gap between what's possible and what we want people to be able to do with it and what people can actually do with it, because there's a big knowledge gap between those two spaces, right? And so what we're trying to do is enable developers to access those boxes of math much more simply and easily from the top down versus having to learn, basically having to go to college for 10 years to get a PhD in physics so that you can use the simulation. And I think that the thing about that is like, what could I do if I could simulate the thing I'm trying to build? And I don't think about it in terms of large companies, but small startups that want to build a new product or want to bring something to market. If I can simulate it, I can cut the time it takes me to build it. I can cut the time it takes me to make sure it'll work when it goes live, things like that. It's a really important thing. And unfortunately, it's been locked behind this giant wall of huge physics formulas for a long, long time. And that's something that we're working really actively to remove. And so what can I do with that? Well, I can make windmills spin. I can make drift cars drift. I can make airplanes take off. And I can make rocking chairs rock. And that last one sounds lame, but if you've ever sat in a rocking chair and it doesn't rock, it's a horrible experience. And simulation can actually help you make all these experiences possible. So Rather than just talk about it and show you slides, I thought I'd show you what we're actually working on. So this is a sneak peek. We use Python pretty much exclusively right now for our library interfaces to our product. And that's because scientific computing and Python sort of go hand in hand. Makes sense, right? To use that. Somebody asked me yesterday, we were chatting, what's behind the hood? Pretty much C, C, C++, C Sharp, even believe it or not, C.NET. But all the boxes of math are mostly in C because of execution speed, and all the interfaces are in Python because of simplicity and access. What I have here is a Jupyter notebook. This is our Ansys lab. So this environment is a fully self-contained box of math running on a cluster somewhere. I don't even actually know where it is. But what this will let me do is this is a really, really simple physics example, but it will let me simulate this beam, and I don't actually have to really know what I'm doing. So that's great for me because I'm not a physicist, I'm a developer. So I will run these computations, and they will run. And you'll notice that something is starting to form here in the visualization. I can, look, that's done. So I can step through the rest. You can see that it is doing calculations in the background. Nope, there's my stresses, and then I can animate it. And now I've built a model of a beam. Pretty simple, nothing like super exciting, right? I mean, it's just it's a beam under stress. What it means is there's very little stress at the top and a whole lot of stress at the bottom. The color, that's what the color coding means. But what's nice about that is I didn't really have to do anything. I just had to give it the points and the coordinates of the mesh, the grid that lives around the beam, which you can get from a 3D model, which anybody can build now in things like Tinkercad and SolidWorks and a million other 3D modeling tools. Once you have that 3D model, you can import it, and then you can test it, see how it will perform under real world conditions. We have documentation, obviously, that tells you what all the variables are and how to submit the model and things like that. But you don't have to understand the physics under the hood completely to generate a simulation, and that's the important part. So the point of this is we want to allow developers to access simulation without having to be physicists to do it, right? And that's what that looks like. And I think, you know, long term, what we want to do as a company, right? And I always say, you know, like, but what if, right? Dream sequence. In our future state world, right? With augmented reality, with virtual reality, we can start to bring those physical simulation models to life. It's actually really not a big step from that really simple 3D beam in PyVista or Dash to a full augmented reality model of that beam that I just simulated. I don't have the skill to write that because I don't work with the visual engine, but somebody who knew Unreal could absolutely take that physical simulation, drop it into Unreal. And now you have a real, live, honest to goodness, physically simulated polygon structure that you could use in a video game, for example. So that's a possible use case that can come from this. But my point in this, and why I bring this to you today as developers, is this is a tough road for us as a company. This isn't particularly easy for us to build this. We didn't start out digitally. We didn't start out working with developers. We've had a closed box system for 50 years, right? We've been around for 50 years as a company. That's a lot of technical debt we've got to pay off. It's a lot of legacy we got to unburden ourselves with. And it's a lot of things that we've got to shed, and that's okay, right? We're getting there. And that journey is what I wanted to talk about for just a few minutes with you all today. It's a tough journey. Basically, every company that isn't already doing tech goes through some version of this journey. I have done this now for 6 companies, Ansys being the 7th. And 7 is a lucky number and a power number, so this will be the best one. I am absolutely certain. But basically, the journey always starts the same way. We need to do something with developers. We should do that. And then everybody runs off and builds something. and I do mean everybody. I can't even count how many people in our organization are building stuff in silos, not talking to each other, just doing stuff, right? Then eventually you get somebody like me that's actually paying attention across the entire organization, across the entire structure of what's going on, and that starts collapsing in on itself. And the ultimate goal is to avoid the black hole effect, right? Because the problem with collapsing is sometimes it results in a black hole, and then everything just washes away. Most of the time, companies get about there, and then all of that stuff just becomes black holes all over the organization. It's very difficult to recover from that. However, if we get it right, which I think we will, you end up in this continuous flow of information. And we all want to do this because, honestly, Microsoft, Google, Amazon, like the tech pioneers of all this stuff, they showed us how to do this. And so the nice thing is we also get to copy some of the things that they did, add our own flavor to it, which is great, right? So we don't have to reinvent the wheel from scratch. But we run into a bunch of challenges, and you probably would think, you guys are developers now. A lot of you are at the beginning of your career. You're going to work your way up. Eventually, somebody is going to approach you and be like, hey, you know how to write code good. Do you want to be a developer evangelist or do developer relations? Do you like talking in front of rooms full of people? And you might make that jump, and you might wonder, well, what does it look like to run this? And the thing about it is, what's it like to run this process from my point of view, having been tasked with that? I do a little bit of tour guiding, and I chose this video specifically because of the guy over her right shoulder in about 2 seconds, because this is kind of what it's like, where he's just like clearly super happy about being on this tour. It's a little bit of a tour guide. You have to be a little bit of a wizard. You have to sort of invent things out of thin air. And a little bit of a traffic cop, a little bit of, hey, you guys should be over there. You should be doing this. Have you talked to these guys? And this is like every day, all day. Yesterday afternoon, when Benjamin said, hey, is there anybody here from Ansys to introduce their talk, their pitch? The reason that I wasn't in the room is because I was busy being a traffic cop. So I had to go deal with a bunch of people trying to do stuff they shouldn't. So it happens. But what's great about it is I get to be on top of all of that, and I get to see this take effect, and I get to see the impact that it has on developers, and that's the best part for me. So a couple of challenges that we run into. There's the David and Goliath effect. I really like this picture, which is why I continue to use this slide. But the David and Goliath effect, a lot of people think that they're David, right? And then they have to, go after these big companies, or it's like the whole like, oh, we're the underdog. The thing about it is we're all David and we're all Goliath at the same time. We have access to all the same stuff, all the same tools. It's just about how you use it, right? It's the same with being a member of a hackathon team. You all have the same tools. You all have the same challenge. They give you all the same data. It's just about how you apply it and your own creativity to use it. And what we try to avoid is we should do what Amazon does. We should do what Google does. We should do what Microsoft does. We should do what insert company X does. We do a lot of things that they do, but we should not try and be them because we aren't them. And I think that's the thing that people fall into that trap. And what I would tell you as you embark on this career is like, keep that in the back of your mind. If you're working for a company and all they try and do is like, we should be Google, you should be working at Google because that's who you want to be, right? Make sure that you focus on what your organization is there for and what they're good at, and then that'll fix things. The other trap that we fall into all the time, which is tough for legacy companies, is the jargon trap. So when I first got hired, and I haven't been in Ansys very long, less than a year now. When I first got hired, they told me, yeah, we have some APIs. You can check them out. They're on GitHub. We started posting them. I'm like, oh, great. You guys are kind of ahead of the curve for a lot of companies that are starting up a developer program. I'll go take a look. And I started reading their API documentation. And I'm like, this isn't an API. You know that, right? And they're like, what do you mean? And I'm like, this is a Python library. Like your very first instruction is pip install. And they're like, yeah, it's an API. And I'm like, that is not what anybody outside of the 5 people on this conference call think an API is. So you run into this a lot in legacy companies that they read something in a magazine and they think they have magically cracked the code of technology. And it's tough. It's a hard thing to overcome. And what I have to do is sort of be the interpreter between what people internally say and what y'all would expect me to say. So when I say, yeah, we have a Python API, everybody goes, what do you mean a Python API? I mean, yeah, you can have an application programming interface that's Pythonic or whatever, but like, can't I just call your API with whatever language I want to use? Like, that's what APIs are for, right? It's a tough one to overcome in a company full of legacy because a lot of people haven't worked anywhere else. A lot of people haven't understood how the rest of the industry is doing things. They've not been to a hackathon. They've not really communed with developers. So it's a thing that I have to constantly do and take over. And I really relish it because it's such a great and exciting thing to help a company sort of come together and break into this space and like mature and understand how that actually works. So it's something for me that I really relish these challenges. That's why I moved out of being a developer and into DevRel and then into running developer relations programs, because I think the challenge is great. So last thought I want to leave you all with is, you know, why should you care about DevRel in general, right? Why should, I mean, you're a developer, of course you care that people want to cater to your needs and desires, and we understand that, but why should you fundamentally care about DevRel? Why does it make an impact on your daily life? And I would say that events like this are obviously the prime example, because it's a really short journey from extremely happy to extremely angry, right? And you know this from working on your projects even now, that when you hit that breakthrough and it's working and you're like, yeah, stoked, right? And then suddenly it stops working, or you commit the next line of code and now it blows up. The developer relations journey is the same thing, and we want to make sure that we're serving this developer audience. So that's why you should care about good DevRel when you see it and when you experience it. And then as developers, make sure you give it feedback, right? Make sure you tell people they've done a good job, because it's important for us to hear from you. Otherwise, we're not going to do what you guys need us to do. So with that, I will leave you. Thank you all for taking time out of your code to come in and listen. And we appreciate you being here, and good luck with your projects. I guess on here. Yeah. Yep. Yeah, so the question, if you didn't hear, what I showed was just a Jupyter notebook, right? And I ran it manually. I hit the play button and it executes the blocks, right? The future state for what we're building and what a lot of our customers are doing is twofold. One, they're building it into a larger workflow. So they're not just simulating a beam, obviously. They're simulating massive, wings of an airplane, whatever it is, right? Sorry. And there's a lot of parts to that. And in a lot of organizations, one person simulates this part and one person simulates this part. One person, and that's stupidly inefficient and terrible. So what they're building is these end-to-end workflows that actually pass the part along, right? So this person does their simulation, those results get fed into the next one, this one goes, this one goes, this one goes. We're getting to the point now where a couple of our customers are even taking that human out of the loop, right? So they look at the results, obviously, because you have to verify, but it's more of a, hey, we're going to simulate this thing end to end, hit start, check at the end, did we get the results we expected at the steps along the way? The other thing that's happening under the hood with that, which I think is probably like the single most important thing we can do with that, is let's say you run a simulation and it just catastrophically fails, right? Like it's just terrible. That beam that I showed you is just all red, right? It's never going to survive the stresses that it's under. We allow you to collect that data and programmatically start to learn what a bad result looks like. And so we can apply that then when you submit the model into the simulation system to say like, hey, before I even bother spending dollars on compute cores to run this, I should tell you it's going to fail, right? And here's why. These are the things that are wrong with it, whatever it is. That extension of capability comes both with the fact that once you programmatically run simulations versus manually, you can run lots more of them, right? So you need a volume of data for machine learning, obviously. And the second piece of that is the more types of workflows you can put under that umbrella, the more types of data sets you can collect and the more accurate your models become up front versus having to wait till the end and then review. So it's kind of twofold. I think the big thing that people want to do is, if you're Boeing, right, one of our customers, you have, I don't know, 2,000 material science engineers on staff, like PhDs. Like, first of all, not cheap, not common, hard to find. It's an aging population, and they're not getting replaced faster than they're aging out of the workforce. What they're trying to do, and what a lot of our companies are trying to do, is basically capture their knowledge into these workflows without needing them physically to be present. And I think that's the bigger win overall for us, is making these workflows more accessible to non-physicists, basically. We were talking yesterday, one of my colleagues is here too, and I always put my foot in it because I joke about how many PhDs work at Ansys, because I'm not a PhD. Like I'm actually the hugest anomaly in Ansys history. I didn't even finish college. I write code good, so they let me stick around. And but we have something like 1,000 PhDs for 4,000 employees. So like we have a high percentage of super smart people. But again, that it doesn't scale, right? Like one PhD doesn't stretch. And so we need to be able to allow people like me who are smart enough to understand what's going on and understand how to use code to get there, right? To be the ones that are driving the workflow that does the simulation. And I think once we get that right, and we're right on the cusp of it, like we're right on the edge of it, it opens up simulation in a much more meaningful way to all kinds of things like this. And like next year, you're going to see us back at HackZurich, if you come again. If you're trying to be one of the 9-timers, or it'll be 10-timers next year. But you'll see us back with a challenge, and it'll be built around something like that, right? It'll be built around how would you take this simulation and then take it to the next step, that kind of thing, right? And that's where we want to go. We want developers to be able to drive simulation because physicists are in short supply. So, does that answer your question? Make sense? Yeah. Yes. Yeah. So right now, I mean, the way that people deploy Ansys is in one of two functions. If you're Boeing, I'll pick on them because I know their environment fairly well. They have 200,000 cores running Ansys, right? Because their solves, the math that they need to do is ridiculous, right? Ooh, nice shot. But it's all physical. They run boxes packed full of GPUs, that kind of thing, right? And again, expensive, time-consuming, painful. We are moving to a platform as a service model. Because again, like not everybody needs 200,000 cores. Like Boeing will always run a huge farm of compute resources to do that, but you and I don't need that, right? I might need 10 or 100, right? And that's where having that SaaS platform as a service sort of model makes way more sense to allow a lot more people access to that solve capability. We already have the platform in place through acquisition, and we're bolting our solver engines underneath it. Now that's an ongoing project. So, yeah. Cool. Anybody else? All right. Thank you guys. Good luck with your projects. I'm really excited to see what people come up with. So, thanks.
Cool speech. Hello, good morning, everyone. Yoo-hoo! We're a small crowd today. Thank you very much for coming to the journey to the Metaverse. When I came in, I felt a bit like there's one video on YouTube, a guy explaining the Bitcoin to a a small group of people. I feel a bit like the same. So we are very early stage with the Metaverse. My name is Maximilian Schmidt. I work for EY in a team called Disruptive Technologies. And I will lead you today through the Metaverse topic. Disruptive tech, we spend our days on topics like blockchain, NFTs, DeFi, DAO, and the Metaverse, which will be the main focus of today. Before we start, the Metaverse doesn't really exist yet, and we'll come to this in a bit. The Metaverse, as we imagine it, is a 3D persistent online universe where different worlds come together, where we can play, meet, work, and do all kinds of things. We, of course, have NFTs involved in the Metaverse to prove that we own stuff in a virtual world. And we, of course, have also cryptocurrencies. The Metaverse is part of Web3. Most of you probably know what it is. It's basically the shift from Web 1, where we have centralized companies, centralized platforms in Web 2, to decentralized platforms, to decentralized networks. These company examples, I'm sure you know all of them. Web 3, we had Google, for example, where we can write. Web 2, we have social media, platforms like Airbnb, for example, we can read and write. And Web 3, we can read, write, own, and participate in the next iteration of the internet, as we call it. In the beginning, I said the Metaverse does not exist yet. Some of the reasons are the characteristics, how we would define the Metaverse. We define it as persistent, always on. There's no limitation on users, so everyone can join. We have things like real-life rendering, a decentralized platform below, and fully functioning economies within these virtual worlds. These different worlds are also interoperable to really form this universe or the Metaverse. We'll have a look at the tech component of it, but a lot of these points don't exist yet. Interoperability, for example, we don't have the standards yet how to combine all these different worlds into one universe. When I said the Metaverse doesn't exist yet, there's a lot going on for something that doesn't exist yet. When we look at the S-curve, it's basically where we stand in the life cycle of technology. The Metaverse is very early. Blockchain, for example, would be roughly here. The Metaverse is, as we can see here, still early. At the same time, we have a market opportunity of billions and up to trillions, if we look at some estimates. When we look at what's going on in the Metaverse, who is joining the space, who is doing projects, there's a broad range of companies, individuals, funds entering the space. For example, of course, we have Nike, who bought Artifact, the digital design agency. We have even the MTV Video Music Awards 2 weeks ago introduced a new category, the best Metaverse performance, where Eminem and Snoop Dogg performed with their virtual avatars, with their bored apes. We have, of course, Facebook changing name to Meta. Cities like Shanghai, Seoul, Dubai entering the space. And of course, Apple, they will release a new headset early next year. When we look at, and of course, EY has a bit of an industry and company perspective on the Metaverse. We interviewed, and I'll keep this slide brief, but we interviewed a couple of CEOs and leaders from companies, what their expectations on the Metaverse are. And it's, of course, how can we create this new environment to reach out to our customers, how we can engage with our clients, how can we make revenue, but how can we also make processes more efficient, and how can we even attract talent in a space like this? And we'll come to a really cool example later on. And of course, the hackathon technology is in the focus. As mentioned in the beginning, the Metaverse doesn't exist for characteristic reasons, but also for tech reasons. The technologies forming the Metaverse are just some of these ones. For example, blockchain, which built the decentralized platform of all of the Metaverse as we would imagine it. We have real-life rendering, which requires a lot of computing power. We have AR, VR, the Oculus headsets everyone probably knows, which are a bit clunky, and the battery runs out after 3-4 hours. That's really a nice start, but it's not where we have to go to really have an always-on, truly immersive experience, how we would imagine it. And now we'll actually jump. Of course, we can't speak about the metaverse and only show PowerPoint slides, even though we're from UI. But we do have some little virtual tour through our EY presence, which we call the EY Talent Tree. It's based on Decentraland. The virtual tour is not going yet. We're trying to figure out some tech stuff, but I'm sure it'll work. Yeah, so the EY Talent Tree is basically our presence in the metaverse or on Decentraland, which is a metaverse-like platform. It has decentralized characters. It's organized as a DAO and has this always-on character. So you can always come and join. There's no pause button. Everyone can come and walk around. I was still trying to figure out tech stuff. The talent tree we use actually for recruiting purposes. And what really makes the metaverse great, and I don't want to advertise EY too much, the metaverse is a really cool place to really bring people together from all around the world. Everyone can come and meet. And we, for example, use this presence for recruiting purposes. So we have this once or twice a month. We have recruiting purposes in Germany, in Italy, in Spain, in Switzerland, where we invite mainly tech talent, because other people don't have a MetaMask or a crypto wallet, to really join us in this virtual treehouse to solve puzzles, to get to know each other, and also to talk with us. As you can see, this is our foyer. We even have our own little NFT EY hoodies. If you want one of these for your Decentraland avatar, you can come to our booth around the corner and claim it. That's my fiery hair, by the way, which I find is really cool. The tree, obviously inspired by sustainability. And we have different floors where we can teleport to and really have a good time with our tech people. And me and my team, we spend a lot of time just walking around there, building these worlds, and really just having fun exploring all the tech that belongs to the metaverse and these kind of worlds. A bit of the boring stuff, which EY has to do, of course, as well. But if you want to enter this world, for example, you have to think a bit outside of the box. Of course, you need to have a cool design. You need to have the tech in place. But you also have to buy the land. You also have to rent the land. If you're a company, where do you store it? Where do you keep the cryptocurrencies for the stuff you want to buy? What's the tax implication? What's the accounting part of it? A bit of the boring stuff. But if you are a company and more professional, you have to think about these questions as well, of course. If you want, we can jump onto the slides back. Thank you. One thing I really find fascinating about the metaverse or Web3 is, of course, the gaming part, which looks cool and it's fun to walk around. But there's a lot. So you might ask, what virtual land? I don't really care. A virtual office? I don't really care. Fair enough. But when we look at outside of what's happening in the gaming world, which I find also fascinating, is what are the other use cases for company which make it really interesting to enter this space? And I brought just a couple. One is, for example, for the automotive industry. Alfa Romeo, what they are doing or will do very shortly, they will bring all the driving data of their vehicles via NFT on the blockchain. So every time you service your car, you maintain it, you go to inspection, this event will be stored on the blockchain. The idea is that when you want to sell your car, you have a very transparent history of the car to prove what's been happening to the car. And when you then want to sell it, you can obviously ask for a higher price. This logic applies to all different kinds of assets. DALL-E, which is also fun, is an open AI generative language model. You can just type in some words and it pops out a cool piece of art. And the other thing, a use case I brought is from healthcare and life sciences, where Siamese twins were joined together on their head, which is obviously a very delicate surgery, and the doctors don't do it very often, but have to prepare quite well for it. So they put the two girls in an MRI scan, and with new software technology, they formed a 3D model out of the MRI data. And then with AR glasses, they could really prepare for the surgery. And the two twins are happy and alive and separated. Yeah, so there's a lot more to it than just the gaming part, which makes it really fascinating. And like I said in the beginning, we're so early, there's so much space and room to explore new use cases, how to bring them alive. And really, I mean, that's what tech, in my point of view, should do, just make things better, really have a purpose and create some value. And the healthcare life science, I think, use case is probably the best example we can imagine. Another couple of points which I think fall under the table very often when you hear these enthusiasts talk about the space is what are the challenges of the metaverse, or quite frankly issues or problems we have to solve with the metaverse. Things like privacy in the metaverse. Companies like, and no company shaming, Meta, they didn't always have the best news when it comes to privacy in Web 2. Now we're in Web 3 with Oculus glasses on. You don't see who you talk to. You don't know who your child is being approached by. We have to keep children, for example, safe in a virtual world where you can't see what they're doing and who they're talking to. I think just a couple of months ago, there was a girl in Germany who met a random guy in a video game, and he ended up killing her. So that's something that is not where we want this place to go. Health concerns in general, mental health. We even have something already that's called VR hangover. So when you are in your VR world a bit too long and you take them off and it's raining outside, you think, oh, the virtual world is so much better than real life. Also something to address. Access inequality, of course. Not everyone now has access to the internet. Now we have the next iteration of the internet. Who will have access to these possibilities? Who can enter these economies? Identity hacking, obviously also a big issue. And quite frankly, also a legal point of view, which law does apply in a virtual world? So there are a lot of unsolved issues. They are all being addressed and being worked on, but there's a lot to do. And yeah, which quite frankly makes it really a fascinating place to work in, or yeah, to be involved in. I think that's it from my side. We have a booth down the line. If you have any questions, I'm more than happy to answer them. And thank you very much for joining us, and have fun at the hack. Thank you.
I'm not sure, can you hear me? Yeah, you do. Okay, so welcome. We will talk about building blocks in XR apps and the Metaverse. I'm Paul. This is the Microsoft talk, but I'm not from Microsoft. I'm from Microsoft partner, AFCA. We are in Bern, and we have also an office in Zurich. And we extend realities. That's what we are doing. We did a lot of projects the last 5 years. One is a city planning project for Zurich, some projects for timber, people working in timber, production plant, and also projects for the ETH, for education. Here especially the lab guide for life science department. If you want to know about us, you can visit our website, and that's the spot for our company. So if we do XR, what we are doing from a very high level, we go from the disk to the space, or from the screen to the world. And of course, in the Metaverse, it could look like this, but there is also a mixed version, let's say, of the Metaverse. So there is also a mixed view. The Metaverse comes to us, if you want to. So if you're working on XR and on the Metaverse, this is a continuum, and you will have to support usually not only VR, not only AR or XR, you will have to support sooner or later kind of a mix of it, or even worse. In one case, it's VR, and in another case, it's AR, and it's the same application. And that brings us to our challenges and the building blocks I want to talk about in this 25 minutes. You see it's a lot, and we have 25 minutes. So we'll keep on high level. I will not go in details, but I'm near the Microsoft place here, and you can ask me anytime, come to me to discuss some more details and go some deeper. So we start with the top row, multi-device, multi-platform user experience. First of all, prototyping. In our experience, the best way is still to do it in analog with just what you have, carton or whatever, paper. If you're more in the Adobe world, you probably could use Adobe Aero or even Adobe XD. If you're more in the Microsoft world, you could use Power Apps. There are some controls in Power Apps. You can do AR. And if you're more in the VR space, and if you are with your prototype interested in the space itself, you could use SpaceXR. Of course, these tools are not very multi-platform, but that's not so important because it's just for prototyping. SpaceXR is for Oculus, as far as I know, only for Oculus. Okay, so let's say you are more like a coder. One choice you have, and this is multi-everything, WebXR. But WebXR is still kind of new, and it's still, it's called a candidate recommendation draft. And if you look, the group here, it started on 2 months ago. So it's very new. I guess this will be the platform that will run the Metaverse one day. But it's not there. It's still in development, the standard, and that means it lacks still a lot of functionality. But we will go there. That's the future, let's say. let's say, do you want to develop in web technology today, you could use Babylon.js. Babylon.js is a open source JavaScript framework. It contains the engine itself, let's say, but there is also a playground. Very convenient. You can do rapid prototyping. There is a material editor, but there is also the sandbox. And the sandbox is you can work with your models. That's the sandbox. So you have, as I said, WebXR, as far as it already exists. But you can do also cross-platform native stuff with Babylon.js. You have, they call it an MRTK, kind of a web-based toolbox for with user controls you can use, and there is also a beta version of a GUI editor. I didn't use that one. We did use the platform for some projects. It's really solid and it works very well. Okay, so this, again, this is like code-first approach. If you're more like a markup-first approach, your choice could be A-Frame. A-Frame is around for a long time. It's solid, it works well, and it does basically the same things as Babylon.js. And of course, there are many other approaches in web. One is Iot framework. It's more like an environment. It gives you an environment in the web, a framework to build environments. And Iot is based on Node.js. And Node.js is a more, let's say, lower level approach. You can do a lot, but you have to do a lot. So it's more like if you want to go closer to the engine or to the WebGL or whatever, it's used, you can use this one. And the opposite of it is ARJS. It's a very lightweight approach, more like a marker-based approach in the web. It could be also interesting for prototyping. And last but not least, there are even game engines in the web. One of it is Play Canvas. Try it out. Okay, so that's the web part. Let's say you can't use web, or you can't use WebXR, or you don't want to use it, you want to do a native app. Probably you will start with one platform, let's say iOS. This is your stack. And then later on you realize, okay, I also need Android, so this is your stack. Then, you think, well, immersive approach would be good, or version, you want to support Oculus, you have even another stack, and then you want to do HoloLens, you have even another stack, and you see the point. So there must be, by the way, we can't do it, we can't have so many stacks in parallel, so we have to reuse our code. And of course, the industry so that's also, and they came together and developed OpenXR. This is application interface where tools like game engines, but also WebXR and other tools can work with. So they go against this API, and then you can deploy it to each and every platform that supports OpenXR. So this is a much better approach, and it's widely supported in the industry. One name is missing, it's Apple. Hopefully they will join also soon. Okay, so how does it look in Unity? Unity is a game engine. So you have Unity on top, you have all the scripts, all the stuff, and then you have the R Foundation and some other toolkit stuff. And then you have this plugin system, it's the blue one. And this plugin system, it hides away, the complexity of the different platforms. And in Unity, you can literally change the platform and it will work. Of course, if you do an AR application with your cell phone or your smartphone or an Oculus, it has a different user experience, sure. And you have to manage that in your code, but that's pretty easy. But all the other stuff, you can use the same code and, of course, the same assets. Especially in XR, there are a lot of assets. Scripts is just one part of it. So this is the Unity approach. And also, if you work with a game engine, you will need to build a lot of UI stuff, let's say. And it's hard to build. You have to do it in 3D. It has to do a lot of things, not only the controls, but also the behavior of the control. It's very important. And you probably want to do that all yourself. So you could use, this is also an open source tool or framework. It's called MRTK. It's for Unity and for Unreal. And basically, it does a lot of user experience stuff for you. You can use it out of the box. It has a lot of controls and so on. And recently, there is a preview of MRTK 3. It came out this summer. It will be, it's a public preview, but it will be general availability availability by the end of the year, they say, hopefully. It's pretty cool because it has a lot of additional features like data binding and stuff like that. Those who work in Unity, it's painful to do that today. So, okay. And I want to mention with the MRTK and in general, make sure you have a way to iterate fast. Because Unity and these engines in general, they take a long time to build it. And if you have to build it and deploy it and then look at it and then start the process again, it takes forever. And the MRTK has this functionality. It's called Holographic Remoting. You install an app, for example, on the HoloLens, and then you can directly run the app on your PC, but see all the output and do also the input on the HoloLens in this case. So it's very convenient. You can just start and stop. It also exists for AR Foundation in Unity. That means for tablets, but it's another tool for tablets and smartphones. But it's important to be able to iterate fast. Talking about iterating fast, there is another way to do, let's say, OpenXR apps, not only for HoloLens, but also for Oculus, for everything that supports OpenXR and the Stereo Kit. It's a code-first approach. It's very lightweight, it's very fast, and yeah, it's actually pretty cool. And you can start very fast. It's those of you who work with game engines, they are very powerful, but they are very heavy. And this guy here is really easy and very fast. And in the end, you get an OpenXR code. You can deploy it to a lot of devices, not to phones. It's really like a goggle thing that it's only for glasses. Okay. Next. Anchoring, spatial understanding, and multi-user interaction. First, anchoring. Let's say you want to develop an app for Koppelbrücke in Luzern, and you want a squirrel that tells a story about the bridge, and people can walk around, and the squirrel comes with them. So you have to know where the user is standing. You could do that by QR codes. You can't do that for obvious reason. You could do it with beacons, Bluetooth beacons. It's kind of hard to do. In this case, it would be possible, but in many cases, it's not possible. It's hard. Some maintenance and so on. You could do it with image tracking. But then people have to have the image in focus of their device, and you have also an additional way to do that, and that's spatial anchors. Think of spatial anchors like, if you have AR, there are features. The algorithm takes the features in the room or in the scene, and spatial anchors then store these features in the cloud. So they take a fingerprint of the place, and the place can be if the same or another device or later, or even another platform that supported comes to the same place. It will recognize and have the anchor again. And we are in the centimeter range, so it's very accurate. So that means you can put an anchor in the world. It's shared with the cloud. Another user then gets the anchor and sees the thing on the same place. And 1 week later, or 2 weeks later, or sometimes another user comes, and he or she will see the same thing. The anchor will be found, and so the skill. Of course, this is a thing you need a lot. Okay, so it's a PaaS service. It's on Azure. It's multi-platform. The anchors can build a graph, so you can do wayfinding. It's cheap or even free, up to 10,000 requests. And these are the use cases I already talked about it. Usually you do the anchoring. I had an example of, where you want to persist anchor for a long time, but usually you need it only for an hour or less. You have a session, you have 2 devices, and you want that they see the same thing at the same place. And you can do that very convenient without a marker or QR code or so on with the spatial anchor. Okay. There are also object anchors, and as you think, this is an object anchor is about an object and not about a place in the world. So you could only upload your 3D model of the object, and it will be recognized in the world wherever it finds it. This is also an Azure service. You should be aware that the object should be kind of big. So not like this, but more like half or a meter. It's more, it works with stuff like that, 20 centimeters or something, but not very good. Okay. There are other ways to do that. Voria is one. There are open source, other open source ways to do that. This is anchoring. Then we have to, if we do XR, if we are not completely in VR, we have to understand the world, or at least know where the world is or where walls are. And the devices do usually a spatial mapping. This is just a mesh on the real world. So you know where stuff is and where you can't go, kind of with your content. But sometimes you have to know more. You have to know, is this the ceiling? Is this the floor? Is this the wall? And there is a scene understanding SDK that's for Unity in this case, but there are other ways to do that for other platforms. And it tells you more. On the right-hand side, you have the spatial mesh. On the left side, you have already some more information of what it is and where it is. So this is important because you want to integrate your app in the real world as good as possible. Okay, talking about integrating, in the world. Usually, especially with HoloLens, you have multiple users, maybe all on the same place, but sometimes some remote users. And you want to synchronize the view. So if two people, or in this case, 5 people, look at the same object and I move it, it should be moved for everyone else too. So we have to synchronize the views. And this is not an out-of-the-box functionality you just can use in these devices. So one way to do that is with a multiplayer engine like Photon. Works very well, it's very fast. But you have to do it kind of a bit. There is an SDK, of course, but you have to still to do some coding and to write some scripts. It's not complicated, but yeah. And in the future, I guess we will have a PaaS service from Microsoft. It's called Mesh. Probably you know Mesh. It's for now it's an application, a preview application for HoloLens 2. You can use it, but it's closed. You can't use it as an SDK. But Satya Nadella said in the last, I think it was built, he said that they are building Mesh as a platform. And I take this as a promise. So, and of course, you could probably have much more functionality here than with Photon. Photon is basically just a platform to share network information, to share it. And with Mesh, probably you could come in on a higher level. Okay, good. Last but not least, cloud offload, conversational AI, and integration of IoT and robotics. Your device, in this case a HoloLens, could be not powerful enough to render really a lot. So, you know, your assets, these are polygons, they're always polygons, and it always depends on how many you have. If you have 100,000, that's not a problem. If you have 500,000, it's not a problem. If you have 20 millions, that could be a problem with your device. And sometimes you can, with a tool, you can change it, change your model and so on, but sometimes you can't. And then you can render it in the cloud and stream it to the device. And these are the numbers. So 250,000 polygons for a HoloLens 2, 20 million polygons for the standard Azure rendering service. And there is even a professional version that's pretty big, 24 teraflops, 42 teraflops. Yeah, it's a lot, but it's also expensive. Don't miss the point to turn it off. It costs a lot, and it costs per device. So if you have 10 devices, you need 10 instances of the remote rendering. Just, yeah. Okay. Another thing you probably will need is interaction. Not, you know, you can't really type on these XR devices, it's painful. So you will need speech. There is speech recognition in the MRTK. We were talking before. It's, as I said, it's more like speech recognition that you define the words. It's more like a, yeah, it's not really for a dialogue. If you want to have a dialogue, you could use the cognitive services for language. You have a language studio, but you have also the language understanding service, LUIS, and this is very powerful, that people can have a discussion and don't have to say exactly this command, but can just say what they want. And the system is then figuring out what's the intent of the user. And that's very, very powerful. And if you need even more, you could also do a bot with the bot framework and then integrate it per audio, of course, with your application. Okay. And then for IoT, there is a service in Azure. It's called Digital Twin Service. It's very attractive actually because it integrates all the different devices. And then in XR, you could use, so this is the system, you know, you have all the digital twins, they are connected somehow, and then you can connect your content, your 3D content in the Metaverse, for example, with this service. And yeah, it's pretty new, but I think if you do, or if you have to integrate IoT, this is a way you should look at. Okay, so yeah, there are a lot of opportunities in XR also, and we did talk all about these challenges. And as I said, I'm around here. I know we are very high level now. If you're interested in one of this technology, just let me know. I'm usually near the Microsoft space. And this is the landing page for the Swiss Re Microsoft Challenge, the Mixed Reality Challenge. And thank you very much.